Hello and welcome back. Today we're getting into 7.2 on inverse transforms. And transformations of derivatives. So the first half of it, inverse transforms, really we're just kind of relying on that table. You don't need to memorize the table. I'll throw it on there like I did previously. Laplace transform of 1 we saw last time was 1 over s, so that implies that the inverse Laplace in the notation shouldn't be super surprising of 1 over s would then spit out a 1. And that will hold for all of our Laplace transforms. So Laplace of, for example, t to the n factorial over s to the n plus 1. That would mean that the Laplace inverse Laplace transform of something of the form n factorial over s to the n plus 1 would give us t to the n. Here we're assuming n is in the set of whole numbers. If we limited it to natural numbers, it doesn't cover this case. If we include the 0, it also covers the top case. Laplace of e to the at we saw in the previous section was 1 over s minus a. So then the Laplace inverse of 1 over s minus a would have to spit out e to the at, and so on. So Laplace of sine of kt was k over s squared plus k squared. So then the inverse Laplace of k over s squared plus k squared is sine of kt. And you have the table in your text, and you'll have it on the test and quiz and such as well. So for any Laplace transform, inverse it, you're back where you started. So you don't technically even really need two tables for that. Just showing one table should be sufficient. So let's practice a little bit with these. I will do the inverse Laplace of s minus 8 over s squared minus 7 times s. That's a messy s squared there. So a couple things that I can do to this. I can factor the denominator, and I can also split the numerator. So then inverse Laplace of s over s by s minus 7 minus 8 inverse Laplace of 1 over s by s minus 7. You can have the 8 either out front or inside. It doesn't matter. We'll come up with the same answer either way. So this first one, we can cancel a factor of s. So now we have the inverse Laplace of 1 over s minus 7. So hopefully you recognize that as an e to the at form. Our next one, though, we're going to have to do a little bit of splitting of that. So then we'll have a little let line, let s 8. Do let 8 over s by s minus 7 equal a over s plus b over s minus 7. So 8 is equal to a by s minus 7 plus b times s. Let s equal 7. and that gives us 8 is worth 7b, so b is 8/7. Let s equal 0, and 8 is -7a, or a is -8/7. So we have minus, and we'll split this up. So a over s, -8/7 times 1 over s, and plus b over s minus 7, so plus 8/7 s minus 7. And we want the inverse Laplace of both of those pieces. Okay, so let me kind of regroup what we've got here. So at the front of the line, we have the inverse Laplace of 1 over s minus 7. Then we have minus a -8/7, so plus 8/7 inverse Laplace of 1 over s. And then at the very end of the line, we have a minus 8/7 inverse Laplace of 1 over s minus 7. So here we have e to the 7t. Here we have 8/7 times 1. And here we have minus 8/7 e to the 7t again. So we have 7/7 e to the 7t minus 8/7 e to the 7t, so that's -1/7 e to the 7t plus 8/7. So that would be our inverse Laplace, so that is our f of t for this problem. All right, so our next one, we'll do a little bit more with inverse Laplaces. Switch that in a little bit. Okay, so next one, we want the inverse Laplace of s over s plus 3, s squared plus 16. If it were a minus 16, we'd go ahead and factor it down. Plus 16, though, we can't reduce it. So we're going to let s over s plus 3 by s squared plus 16 equal a over s plus 3 plus bs plus c over s squared plus 16. So the reason I have two terms, as a reminder, this is an irreducible quadratic. So just like the first powers have basically a 0 power above, second powers would have a first power above, so we need both a first power and a constant. Sometimes one or both of them ends up as a 0. It varies from problem to problem. So then we have s is worth a by s squared plus 16 plus bs plus c by s plus 3. Now we can get a value for a almost right away. Since this guy is a nice, pretty linear, we can just let s equal -3. And -3 is worth a by 9 plus 16. The others drop off. So then a is -3/25. All right, so then we'll continue on the next side here. So we still have s is equal to we have a over s plus 3. 8, my apologies there. S is equal to a times s squared plus 16 plus bs plus c times s plus 3. So now we're picking different values of s. We already used up the -3. 0 is always a fairly simple, straightforward one. Let s equal 0. So then 0 is worth a times 16 plus b times 0 is 0, so c times 3. So now we have a value of a, so we can just plug that in. So a is -3/25, so we have -3/25 by 16 plus 3 times c. So 3c is worth 48/25. So I just moved the 48/25 over, and then we'll divide through by 3. So then c is 16/25. And now we just need to find out what our b value is. So for that, we'll just let s equal some other value. 1's not bad to work with. So 1 is worth a times 17 plus b plus c times 4. And then we have values for both a and c. We'll plug those in. So 1 is worth, a is -3/25. Hang on to your 17. For b, and 4 times 16/25. So 1 is worth -51/25 plus 4 times b plus 64/25. So 1 is worth 4b plus, so that'd be 13/25. So 25/25 minus 13/25 would be 12/25. It's worth 4b. So then b is worth a quarter both sides, so 3/25. Okay, so we have our Alpha, Bravo, and Charlie in hand. So let's break this guy up. So then our f of t will be inverse Laplace of, we had a over s plus 3, so -3/25 over s plus 3. And then we had plus bs plus c. So plus b was 3/25. 3/25 s. And we're doing still the Laplace inverse of s, bs plus c. c was 16/25. And that was over our irreducible quadratic. Okay, so once again, we'll do a little bit of separating. So f of t, -3/25 inverse Laplace of 1 over s minus a -3. Then we have plus 3/25 inverse Laplace of s over s squared plus 16 plus 16/25. Leave a little bit of room here. Inverse Laplace of 1 over s squared plus 16. We're very close to the format we need, but when we have this s squared plus k squared at the bottom, we also need a k at the top. So k here would be 4. I'll multiply by 4 inside and 1/4 outside, similar to what we do with integrals. So f of t is now -3/25 e to the negative 3t. So just applying the work from the table, plus 3/25. And if we have s over s squared plus k squared, that is a cosine. So this is cosine of 4t. Then we have plus 4/25. And then k over s squared plus k squared is sine of kt. So sine of 4t. So that is our Laplace transform for that. So now that we have some Laplace transforms under our belt, now we look at, okay, well, how do we start applying these? And that is we use the definition for transform of a derivative. So the idea here, we're taking the Laplace of an nth derivative of some function. We're assuming that it's defined on 0 infinity. So this will give us s to the n, cap f of s, we'll define cap f in a moment, minus s to the n minus 1, f of 0, minus s to the n minus 2, f prime of 0, minus, and then we keep doing that until we finally get down to basically s to the 0, f to the, we'll have n minus 1 of these derivatives of 0. S to the 0, sometimes they write it in, sometimes they don't. S to the 0 is just a 1, so usually they'll write it without it, but it's kind of a good indicator of when to stop. And here, cap f of s is the Laplace transform of function f of t. So we're not going to prove why this works or anything. We're just going to be asked to sort of put it in motion, work with it. All right. So we'll put this to work on y double prime minus 4y prime is worth 6 e to the 3t minus 3e to the minus t. And initial conditions, y of 0 is 1, y prime of 0 is negative 1. All right, so kind of one piece at a time, the y double prime, we're going to do the Laplace on that. The Laplace of y double prime, so n here is 2, so we'll have an s squared cap f of s minus s to the 2 minus 1 is 1, f of 0. You can write it as y of 0 if you'd like, because these were written in y. Y of 0, f of 0, I'm not super concerned about. Minus s to the 0. Now I know this is going to be my last term in here, f prime of 0. So that much is our y prime. Then we'll have minus 4 times, and we'll do the same thing with our first derivative. So here we're doing the Laplace of f first derivative of t. So n is worth 1, so s to the 1, cap f of s, minus s to the 1 minus 1 is 0, f of 0. And then that's, I have to wrap around here, equals 6e to the 3t minus 3e to the minus t. And we'll do the Laplace transform on both of those guys. So left side, sort of plugging in our known values for the initial conditions, we'll have s squared cap f of s minus s to the first is just s, and f of 0 or y of 0 was worth 1. minus s to the 0 power is a 1, f prime of 0 or y prime of 0 is a negative 1. Distributing the negative 4, we have minus 4 s cap f of s, and minus 4 times 1 times f of 1, or f of 0 is 1. That's equal to 6 times the Laplace inverse, or Laplace of e to the 3t 1 over s minus 3. Do the same thing with the next term. Minus 3 and e to the minus t is 1 over s plus 1. Minus a negative 1 flips it over to a plus 1. All right, so a little bit of sorting work coming up. Cap f of s was attached to an s squared and a minus 4s. Then we have a minus s, and here we have a plus 1 and a minus and a minus 4. There, caught that. Minus a negative should have flipped my sign to a plus there. My apologies. Once I flip back here, distributed this negative to this negative, that should have been a plus 4 times 1 times 1. So that would be a plus 1 plus 4, so this is a plus 5. My apologies there. And this is equal to then 6 over s minus 3 over s plus 1. Okay, so I'll move the s and the 5. Cap f of s times s squared minus 4s is s plus 5 plus 6 over s minus 3 over s plus 1. So cap f of s is s over s squared minus 4s plus 5 over s squared minus 4s plus 6 by 6 over s squared minus 4s by s minus 3, and minus 3s plus 1 by s squared minus 4s. So cap f of s, you can see we can factor an s from everywhere, top and bottom here, and then we have a 1 over s minus 4. Then we have 5 over s by s minus 4, 6 over s by s minus 4, s minus 3, minus 3 over s plus 1, s minus 3. So lots of work with partial fractions coming up here. For the sake of brevity, I'm going to kind of fast forward us through that. This one didn't need it. So 1 over s minus 4 will keep. This one turned into a 5/4 over s and a negative 5/4 over s minus 4. This guy got split into 3 pieces, so we had a half over s, a minus 2 over s minus 3, and a plus 3/2 over s minus 4. And then this guy we split into a plus 3/4 over s minus 3/5 over s plus 1, and a minus 3/20 over s minus 4. So again, a little bit of work with partial fractions, partial fractions, partial fractions. So we have some like terms that we can handle there. So the s minus 4s, this guy, this guy, this guy, and this guy, and that'll land us at 11/10 by 1 over s minus 4. Then we have our 1 over s's. Yeah, this guy, and this guy. So that gave us a 5/2 by 1 over s. The 1 over s minus 3s. Only one of its kind. Bring it along. And the 1 over s plus 1s. Again, the only one of its kind. Bring that along. This is a 5 here, not an s down here. Over s plus 1. Okay, so this guy, when we do the inverse Laplace, which will get us back to f of t, inverse Laplace of this whole thing, 1 over s minus 4, that's already in the right form. 1 over s is already in the right form. Two times 1 over s minus 3, we're good to go there. If you really want, you can rewrite as s minus a negative 1. You don't necessarily have to. And we want the inverse Laplace of each of those. So f of t would be 11/10 of, this would be e to the 4t. So now I'm just using the tables. 1 over s turned into a 1. 5/2 times 1 is just 5/2. I have minus 2 times e to the 3t. And minus 3/5 e to the negative t. So that's as far as we can go. This is our particular solution to the initial value problem. So this is just one more new method that works in some places that the other methods don't necessarily work as well with. So in 7.2, I would recommend 1 through 39 on the odds. If you have any questions, please feel free to get in touch with me, and I will see you next time. Stay safe out there.